Well, I hope you guys are having a great weekend. Thank you for tuning in to Mr. Kramer's review of exponents and logarithms. We have some interesting problems here that I would like to take a look at. First of all, if you would go down to the bottom of your worksheet, we are looking at rewriting the equation from exponential to logarithmic, and going the other way, going from logarithmic to exponential. Now, we have done this. We've gone from logarithmic to exponential, but we haven't gone the other way. So let's take a look at this. Let's just review. So here we're in logarithmic form, and we want to go to exponential. So what do we write down first? Good, Christian. That's right, the base. Okay? So the base is 3. And then what number represents the exponent? Correct, 6. And it's going to be equal to the argument. There you go. We went from logarithmic to exponential. Okay, something new. No number. You know, math is full of assumed numbers, numbers that are there but you don't see them. For example, if you had x plus 2. Okay, what is the number in front of the x? Why, it's a 1, of course. Okay, if I have x times x, what's the number, what's the exponent? Why, 1, of course. Okay, and also we have this radical, square root of 25. What's the root? Why, 2. We don't write it, but we know it's the second root of 25, which is 5. So math is full of numbers that are not written, but you need to know that they're there. So here, well, what's the base? When the base is missing, okay, it's 10. When the base is missing, it's 10. And that's called a common logarithm. When it's a base 10, it's a common logarithm. And that's what your calculator uses. When you press the log button, okay, it's going to give you base 10. Okay, so I don't think we have to go into changing that. It's just like this one. Okay, now let's go the other direction. Here we're in exponential, and we want to go to logarithmic. Okay, so to do that, we just need to know what the different parts are, okay, and put them in the correct place. So we're going to start off by writing the log. Okay, what's the little number represent? Base. That's right. So we have a base of 625. Okay, so the base. Next, what's the argument? Okay, if you can't remember, look back here. Okay, what's the argument? The argument is the answer to the exponential problem. So the answer to the exponential problem is 5. And don't forget, the answer to a logarithm is an exponent. Okay, so I'm going to let you do this one, and of course this one for practice. Okay, let's take a look. Turn it over. It says evaluate each expression, give an exact answer. Okay, so since we're in logarithmic form, our answer is our unknown, so I'm going to use an x for our unknown. So base is 4, so 4 to the x power equals 1024. Now if you remember from one of my previous videos, in order to solve this problem, we need to get the bases the same. So can we think of 4 to some exponent that gives us 1024. And I got it right first try. I just guessed 4 to the 5th power. So 4 to the 5th power is 1024. Okay, so that's going to be, I guess, you might want to use another piece of paper because I'm running out of room here. So this is 4 to the 5th power. So x equals 5. X equals 5. All right, let's take a look at 28. All right, let's see how good your memories are. All right, hopefully it's not after midnight. What type of log is this? What type of log is this? If you said common, you're correct. Excellent. Excellent. It's a common log. Base 10. Anytime we have base 10, common log. So we're going to put the 10 in there, we're going to put the x in here, and we're going to do 10 to the x power equals our argument and solve for x. I'll let you guys do that. Let's see. Think you guys can handle these? No problem. No problem. Think you can handle those? If you get stuck, we're going to go over it on Tuesday. Properties of logarithms, you can do that. Use the properties to solve the following, you can do that. Okay, bonus material. Yes, bonus material. So, what type of log is that? Common. Logarithm. Yeah, base 10. Okay? I'm going to introduce you to a natural logarithm. Natural logarithm, it's called natural logarithm because it occurs very frequently in nature. It's found. But basically, it's going to be log base e. Base e. Okay, e is like pi. It represents a number, and it's on your calculator. Let me show you where you can find base e. Let's see. See if I can remember. Yeah, here it is. If you look on this button here, the blue, it says e to the x. Second, we press that. E to the x, base e. I'm trying to remember. Let's see. Let's just raise it to the first power. So e, this is the number that represents e. 2.718281828. Okay, notice the repeating. 1828, 1828, 1828. Keeps on going. Okay, that's what e is. Okay, I found it over here. Over here on the division symbol. See the e? So let's see if that works here. We're going to do second, divide. There's e, and there's your number. Okay? Now, it occurs so frequently in nature that they've given it its own special symbol. So rather than writing this for a natural log, we're going to use ln. ln. Well, I guess I'll make it a capital L. ln of x. ln of x, the natural log of x. And that button is found right here on your calculator, the natural log of x. So if I want to find the natural log of 100, and there you go. Natural log of 100. So if I was to solve this problem, let's see. Let's just make it like that. So first thing we would do is we would put e to the 100th power equals x. Okay, then we would go on here and we would do second ln. Okay, notice you got the e to the 100th power, and that would be a really big number. Basically it's rounded to 7, 2.7 times 10 to the 43. So anyway, little additional information. See you guys on, well, it depends. I know my morning classes I won't see because of the ELC testing. I might see my afternoon classes. I haven't seen a schedule for Monday yet, but I'll definitely see you all on Tuesday.